Okay, this time we're going to draw an electrolytic cell. So if you remember, we drew our electrochemical cell by looking at our table of reduction potentials. We figured out that copper lies above zinc in our table of reduction potentials. That means copper happens as a reduction. Reduction is at the cathode. Zinc has to flip and become an oxidation. Oxidation occurs at our anode. So zinc is at the anode on the left, and copper, which is the reduction, red cat, reduction is at the cathode, red right, the cathode is on the right. So we drew our electrochemical cell, and we put our zinc, our oxidation, on the left. We put our copper reduction at the cathode on the right. Now, in an electrolytic cell, electrolysis is the opposite. We provide an external voltage and we drive the non-spontaneous reaction. So we're going to flip the position of the copper and the zinc. So copper this time is going to be at the anode, and zinc is going to be at the cathode. Now, we still have the anode on the left and the cathode on the right. But in electrolysis, the polarity of the anode and cathode is reversed. The anode is forced to be positive. And I do this by adding an external power source. And the external power source provides the energy to move electrons, and they still move from left to right in the external circuit. So because I have oxidation still occurring at the anode, copper is oxidized, and the two electrons travel through the external circuit. Those same two electrons are being provided at the cathode, and Zn2 plus from solution is picking up those electrons and becoming zinc solid, being reduced. Now, as electrons are moving to the right in the external circuit, anions are moving left, and cations are moving right. Anions are leaving the cathode half cell, just as cations are leaving to keep charge balance. Cations are leaving the anode half cell. Salt bridge is still filled with sodium nitrate. So our reactions here, we have copper producing Cu2 plus 2 electrons. E naught is negative 0.34 volts. And at the cathode, we have Zn2 plus plus 2 electrons make Zn. E naught is negative 0.76 volts. Our overall reaction, Cu solid plus Zn2 plus, will make Cu2 plus Zn, and E naught is the total of the two, negative 1.10 volts. Notice the sign of E naught is negative, indicating an electrolytic cell. that voltage has to be applied, and it drives a non-spontaneous reaction.